Hi everyone, welcome to section 1.3 of your notes. If you have your skeletal notes available to you, you're going to want to get those out. For the rest of you, just take notes as you need it. At the end of this, make sure you do take a picture and upload a picture of your notes. All right, here we go. Let's get started. So last section we talked about segment addition, where we can have one length of a segment plus another length to equal the whole. And then we added some algebra into the mix there for those of you guys who have been missing algebra in your lives. There you go. So now today we're going to get into two specific types of things that can happen with line segments. And the first is a midpoint. So a midpoint is the point that divides the segment into two congruent segments. And remember, congruent segments are segments that have the same length. So if we can find a point that's exactly in the middle, then the length to the left should be exactly the same as the length to the right, which makes it the midpoint. We have a formula that we use. It looks very complicated, but it really isn't too terrible. So take a moment to jot this down. We use a capital M to represent midpoint. And then your midpoint is going to be some ordered pair. Remember, ordered pairs are x comma y. So to find the x, what you do is you take your two x's, so x sub 1 plus x sub 2, and you divide it in half, because that's how you find the middle of something. You cut it in half. And then you do the same thing with your y's. So y sub 1 plus y sub 2, cut in half. We also have what's called a segment bisector, which is very similar to a midpoint. It's just that it can be any really type of any geometric figure. So a segment bisector can be a point, a ray, line segment, or even a plane, though you probably won't see that happen too often, that intersects the segment at its midpoint. So for some examples, here are some examples. We have line segment AB on the top with a point being the segment bisector, which is point M, also known as the midpoint. Or we have line segment AB on the bottom being bisected by a line at point M. So pretty much whenever you see the word midpoint, or, I guess I should write out point, midpoint, or bisector, we should be thinking cut in half. Okay, so midpoint or bisector, just always think that you're cutting something in half, because when we get to the algebra, you're going to be doing that. Okay, so let's go to our first example. Now I apologize, this diagram is not drawn to scale. I did not do a good job of creating this diagram myself. We're going to pretend that T is in the middle, though T clearly does not look like it's in the middle. But we're going to pretend that line segment VW bisects. So bisects means that we're going to cut it in half. I don't know if any of you guys have watched any Full House. Remember, cut it out? No? Anyways, okay, so we're cutting it in half. That means that the right and the left are going to be the same length. Then we are told that xt is 39.9, so that's 39.9 centimeters, which means the other side would have to be 39.9 centimeters, because if it's in the middle and it's cutting it in half, then we have two equal sides. The left is equal to the right. So the question is asking us, find xy. And remember, what does it mean when we have no symbol? No symbol means find the distance or the length. Distance or length. Okay, so adding those together would get us the whole entire length. So fancy calculator is going to do the math for me. 39.9 plus 39.9 gets us a total of xy equaling 79.8. Because we had units, we should put them in there, centimeters. Remember, xy with no symbol above it means we're finding the length between x and y, or the distance between x and y. Okay, let's go ahead and work through this one. Point M is the midpoint of line segment VW. Find the length of VM. So because we were told that this is a midpoint, that means the left and the right are exactly the same. If the whole is 46, remember midpoint, cut it in half. What's half of 46? Well, 23, which makes this half 23. So we're asked to find the length of VM, which would be 23 units. Okay, so I'm going to have you try one on your own. Let me quickly make up a new one. Whiteboard, there we go. Okay, so we've got line segment AB. And we have line N. So line N bisects line segment AB at point, let's make that a T, why not? Point T. Okay, we're given that AT is 10. I want you to find the length of AB. Did you say that AB was equal to 20? Hopefully you did. So all we had to do was take 10 plus 10. So remember, bisects means cuts in half. So you got two equal halves. Left is the same as the right. Awesome. All right, so now let's throw some algebra into the mix here. So we are told that point M is the midpoint of line segment VW, which means your left is equal to the right. So if the left is 20, that means the right should also be 20. So we need to figure out what value of x in that algebraic expression would get us 20. So how do we do algebra? Well, we're going to set that algebraic expression and set it equal to 20. Adding 1 to both sides gets us 3x equals 21. Dividing by 3 gets us x is equal to 7. Look up at the answer. What's it asking us to solve for? Solving for x, so I know that I am done. So circle it. There's our solution. Before we move on to the midpoint formula, let's try one on your own. So let's go back to the line segment AB. I know these are not on your notes, but see if you can just do them. Midpoint M, we know it's the midpoint because I have 2 tick marks there. We'll have this be 15, and this is going to be 2x minus 1. Solve for x. Did you get 8? Hopefully you put 15 is equal to 2x minus 1. Adding 1 to both sides gets you 16 equals 2x. Dividing by 2 gets you 8 equals x. Done. Nice job. Okay, so now let's get into using the midpoint formula to find a midpoint. So remember graphing on a coordinate plane. If I need to graph, I know this is not your notes, just watch. Here's a coordinate plane. Remember, oops, here's your y-axis, here's your x-axis. Quick refresher of plotting points. If I had to plot the point, I remember what it was, but let's say if I had to plot point 1, 2. Remember, this is your x, this is your y. This is your x movement, so this is your left or right movement, this is your up or down movement. Because I'm going to the positive 1 direction on my x-axis, I'm going over 1 unit to the right. Because I'm going up 2, I'm going to go up 2 to the right. So going over 1, up 2 will put me right here. If I had to plot the point -3, 5, remember this is your x, this is your y, then I would go to the right -3, so 1, 2, 3, up 1, 2, 3, 4, 5 would put you all the way up here. Okay? Now, if I wanted to connect those, now didn't I just create a line segment? Sure. And then we could use the midpoint formula to figure out where we think that coordinate would be. That would be exactly in between those 2 points. So let's go ahead and put that to work. So remember, our midpoint formula is big M is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It may help to label your points. I'm going to call R my point 1. So I'm going to make that an x1 and a y1. Don't make it x1, x2. You have an x and a y at each point. I'm going to make point S be my second point. So that's going to be an x sub 2, y sub 2. We just use that subscript to identify point 1 and point 2. Okay, so now when I plug it in, x sub 1 is 1. X sub 2 is 4. Cut that in half. Do the same thing for your y. Negative 3 plus 2, cut in half. 1 plus 4 is 5. 5 cut in half. Just leave it as 5 halves. Negative 3 plus 2 is negative 1. Cut in half is negative 1 half. I like fractions for my answers, so you can just leave it as is. Midpoint formula. Okay, we're going to actually skip this problem. So if it's on your sheet, cross it off. And let's move to the distance formula. So distance formula looks very complicated. Take a moment to jot this down. Remember, AB with no symbol above it means we're finding the distance between A and B, or the length of A and B, however you want to say it. And it's equal to a giant square root sign. And underneath it, you have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Pause this video if you need a moment to write that down. I'm going to move on. So let's go ahead and use the distance formula to solve for the distance between R and S. So again, I'm going to label x1, y1, x2, y2, and R and S, the distance between the two is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now plug in your numbers. X sub 2 we have is 4 minus x sub 1, which is 2, and we'll square that difference. Do the same thing for y sub 2, negative 1 minus y sub 1, which is 3 squared. Keep going. 4 minus 2 is 2, and then I'm going to square that. Negative 1 minus 3 is negative 4, then I'll square that. Keep going. 2 squared is 4. Negative 4 squared is 16. Be careful if your calculator is lying to you and telling you that it's negative 16. Whenever you square a positive or a negative number, you get 16. 16 plus 4 is 20. So now on my calculator, I'm going to do the square root of 20, which gives me, if I do 2 decimal places, 4.47 would be our distance. Okay? Try to round your answers to 2 decimal places. I forget if the book asks for 2 or 1, but go to 2. And that concludes our notes. Move on to your next task. Bye, guys.